In 7.2, we're going to be exploring rational exponents. So we're going to be looking at radicals as rational exponents. So objective 1, you're going to learn how to use exponential notation for nth roots. So for example, if you had the nth root of a, then you could rewrite it as a to the exponent 1 over n. Okay, so if you plugged into your calculator the square root of 4, we know that we get 2. If you were to plug into your calculator 4 to the exponent 1 divided by 2, you would also get 2. So the denominator of a rational exponent is your index. So if you had 8 to the 1/3, the denominator of your rational exponent is your index. Again, the denominator of your rational exponent is your index. Okay, so if I asked you to evaluate 32 to the 1/5, I'm asking you to take the 5th root of 32, which hopefully you guys know is 2. So again, you could plug this into your calculator as 32 to the exponent 1/5 in brackets, or you could do it as the 5th root of 32. So for this one, again, the index, so the denominator of your rational exponent is your index. So the square root of 64, again, when it's a 2, we don't have to write it. So that would be 8. Okay, so now they're going to get some negatives thrown in there and some different things. I recommend you pause the video, try to solve these on your own, and then unpause the video. Okay, so for this one, this is the 4th root. Now, is it the 4th root of -81 or the 4th root of just 81? Hopefully you're all yelling at your screen and saying it's the 4th root of just 81. It's not in a bracket. Whereas this one, because the quarter exponent is on the -181 in brackets, this would be the 4th root of -81. So for this one, so -1 times the 4th root of 81, the 4th root of 81 is 3, so this would be -3. Whereas this one, because this is an even index, you cannot take an even root of a negative number. So this one would be undefined, no solution, whatever you like writing. For this one, this is the 3rd root of 1 over 27, so you could write that as the 3rd root of 1 over 27, or you can think of it as taking the 3rd root of 1 divided by the 3rd root of 27, which is a third. Okay, so now what we're going to do is add some exponents in there as well. So if I have a to the m over n, again, the denominator of your exponent is the index of your radical. So if I wanted to rewrite a to the exponent m over n, so if I wanted to rewrite my rational exponent as a radical, you're just going to take that denominator and put it in the index. Now you'll see that there's 2 ways of writing it here. This is straight from your textbook. This one you've got a to the m, and then you're taking the nth root. This is the nth root of a, and then all to the exponent m. It doesn't matter. You can do it in any order you want. You can take the root first and then use the exponent, or you can do the exponent and then take the root. I tend to like to do it this way because I like to make my number smaller before I make it bigger, but it really does mean the same thing. So for example, if you look at this one, first thing I want to do is write each radical exponential as a radical. So I'm going to rewrite this as the 4th root of x. Now, I want to cube this. I can either do the whole thing cubed, or I could take the 4th root of x cubed, and no preference. You can do whichever one makes the most sense to you. All right, it does say here, assume that all variables represent positive real numbers. Hopefully you know why, because as soon as you have an even root, you need to make sure that you're only taking the root of positive numbers. So for this one, it would be x has to be greater than or equal to 0. But that's why it says that here. Assume that all variables represent positive real numbers, so you don't have to write that in there. All right, with this one, again, you can pause the video right now and give these a go, or you can keep watching. In this one, I hope you realize that the rational exponent of 2/3 is only on the x, not the 14. So this would be 14 times the cubed root of x squared. All right, the next one. So again, this one's in brackets this time. So this one would be the 5th root of 2x all cubed. Now I wrote it like that. I mean, I guess you could go the 5th root of 2x all cubed. If I wrote that, I'd be even tempted to go the 5th root of 8x cubed. You know, you kind of have to look at what the answers in the textbook look like for what they're looking for, but all 3 of those would be accepted. This one is the 3rd root of the bracket. So you got 3rd root of that entire bracket, which is x cubed plus y cubed. And you cannot take the cubed root of that. That is just the answer right there because of the plus sign. Plus signs are stop signs. All right, next one is going the other way. So now if I write something as a radical, can you rewrite it in exponential form? And again, your index is going to become the denominator in your exponent. So this is the square root of 37. So that would be 37 to the exponent 1/2, because there's no exponent here. You can't see it. It's a hidden 1. So it'd be 1 over 2. In this one, this would be x squared, and then the index becomes your denominator. It also says simplify if possible. So I'm going to write this as x to the 1 or just x. In this last one, again, the exponent goes on top, the index is the denominator, and if you can simplify, please do. So this is the first part of the process, is being able to just write or recognize that a rational exponent is a radical and that a radical can be written as a rational exponent. The next one is more along the lines of, can you simplify? So if I give you something like 8 to the 2/3, you know that that's asking you to do the cubed root of 8 all squared. So the cubed root of 8 is 2. 2 squared is 4. You could have also done this as the cubed root of 8 squared. So you get the cubed root of 64, which again is 4. So again, it does not matter whether you do your root first or your exponent, you'll get the same answer. Now I'm doing these like I don't have a calculator. Your calculator can do fractional exponents. If you do 8 to the exponent, 2 divided by 3, it will give you 4. The downside of that is later on we're going to be doing more with radicals, and the more radicals you can do in your head, the better. So challenge yourself. Try to do these without a calculator and see how far you can get. So again, you can pause the video and give these 2 a go if you want. So for this one, that negative's out front, the exponent is only applied to the 16. So this would be -1 times the square root of 16 cubed. So again, I like to do my radical first because it makes my number smaller. So the square root of 16 is 4, and then that still needs to get cubed. So this would be -64. This last one, we've got the -64 in a bracket. So I'm going to do the cubed root of -64 squared. Okay, and again, it wouldn't matter if I did the squared first or if I wrote this as negative, or the cubed root of -64. I don't need the brackets, I just keep doing it squared, which is the way that I would do it. So the cubed root of -64 is -4, and then I'm going to square it to get 16. All right, and we can throw negative exponents in here. So negative exponents work the exact same way that they worked in chapter 4. The negative exponent means you're in the wrong place. So this would be 1 over 16 to the 1/4. And so I would write that as 1 over the 4th root of 16, which is 2. For this one, the negative's in front. It's not on the exponent. So this is just negative the 4th root of 16, which is just -2. And lastly, I'm throwing in lots of negatives here. That negative on front just stays in front, and then the -1/4 applies to the 16. So this would be 1 over 16 to the 1/4. And again, the answer would just be negative 1 over the 4th root of 16, which would be -1/2. So same question 3 times, just changing where the negative signs go and seeing how that affects your result. So give these 3 a go, unpause the video, and then we can go through the answers. So looking at this first one, the negative's on the exponent, so it'd be 1 over 81 to the 3/4. So this would be 1 over the 4th root of 81 cubed. The 4th root of 81 is 3. 3 cubed is 27. I forgot the 1 over. Easy places to make mistakes. Okay, this next one, again, it's 1 over 36 to the 3/2. If I was going to evaluate 36 to the 3 halves without a calculator, it's the square root of 36 all cubed. So the square root of 36 is 6. Ooh, if you know this one, I'll be impressed. 6 cubed is 216, and I only know that because I've taught this course a million times. I would, of course, be grabbing a calculator for that one. But the key thing in this is that don't plug into your calculator 36 to the exponent negative 3 halves. And the reason that I don't want you to plug that in is it's going to give you this as a decimal. So if you are using a calculator for these, make sure that you're putting it as 1 over, and then you could plug this into your calculator. You could do 36 to the exponent 3 halves, or the square root of 36 cubed in your calculator, and get that 216. All right, when we have a fraction to a negative exponent, what you can do is flip the entire fraction, because this is 64 to the negative 3 halves over 25 to the negative 3 halves. We apply the power rule. So what we're going to do is flip it. It's going to be 25 to the 3 halves over 64 to the 3 halves. And then we're taking the square root of 25 cubed over the square root of 64 cubed. So the square root of 25 is 5. 5 cubed is 125. The square root of 64 is 8. Or sorry, the cubed root of 60. No, square root of 64. Sorry, I'm looking at my note keys and realizing that I made a mistake. The square root of 64 is 8. I'm going to have to plug this into a calculator. The square root of 64 is 8. And then 8 cubed gives me 512. So the final answer, you always want to make sure if you can simplify 125 over 512, you want to see if it simplifies and there's no number that goes into both, and so that would be your final answer. All right, we're going to take a break before we apply the exponent rules.